We're on page 56, and the problems we're going to do from question number 6 are F and J, and then we're going to do from number 7 on page 56, we're going to do B right here, we're going to do G right here, and finally J. So we go to our first problem, which is 6F. We've got to multiply 2x plus 3 times this bracket here. So what we're going to do is take the first term here and multiply it by the complete second bracket, and then we're going to take plus 3 and multiply it by the complete separate bracket. So we see right here I took the 2x, which is the first term here, and multiplied by the contents of the second brackets, 4x squared minus 6x plus 9. And then I took plus 3, including the 3 plus right here, and multiplied it again by the contents of the second bracket. Now, when we now use the distributive rule, because I'm going to multiply 2x times this, 2x times minus 6x, and 2x times plus 9, and then go through the same thing here, the 3 times the 4x squared, the 3 times the minus 6x, and the plus 3 times the plus 9. So let's do the first part here. 2x times 4x squared gives us 8x cubed. 2x times minus 6x gives us minus 12x squared, and 2x times plus 9 gives us plus 18x. Now we're going to do plus 3 times 4x squared gives us plus 12x squared, plus 3 times minus 6x gives us minus 18x, and plus 3 times plus 9 gives us plus 27. So now what we're going to do is group the numbers in terms of descending powers of x. So we start with the highest power of x, which is 8x cubed, and the minus 12x squared, and the becomes this right here. We're going to move the plus 12x squared right over here. So we get the squared terms. Now we started with the highest power. There's only one term here, 8x cubed with power 3. There are two terms with the squared power, minus 12x squared and the plus 12x squared, here and here. Now we go to the next power of x, which is x to the power 1. We've got plus 18x and minus 18x. So plus 18x minus 18x. And finally, we've got our number, which is really times x to the 0, so our 1. So the lowest power of x is right here, x to the 0. So we now have these in terms of descending powers of x, and we can group them because I can only add and subtract the terms that have the same power. So 8x cubed is by itself, it's like there, and minus 12x squared plus 12x squared is 0. These two cancel to give you 0. Plus 18x minus 18x sum to 0, so there's no term in x, plus 27. So we're really reduced to the first term and the last term because all the other terms sum to 0. Now, if you look at the original equation, there's another way to look at this. It's to realize that it has the form a plus b, a squared minus ab plus b squared. So this is a plus b, a squared minus ab plus b. Now, a is 2x and b is 3. And this simplifies to a cubed plus b cubed when you multiply this times this, you'll get a cubed plus b cubed, which is essentially what we have over here. A is 2x, b is 3. So we have 2x cubed, a cubed, plus this. So it's just a different way of looking at this problem. You shouldn't memorize this, but you can see that this simplifies to a cubed plus b cubed, and our original equation was in the form a plus b, a squared minus ab plus b, where a and b are identified this way. So if we go to this problem here, we take the first bracket and we multiply it, or the three terms that are in the first bracket, and we have to multiply by the three terms in the second bracket. So what we're going to do is take the first term, x squared, and multiply it by the contents of the first bracket. X squared times the contents of the first bracket. Now we're going to take plus 2x, which is right here, multiply it by the contents of the second bracket. And finally we're going to take plus 1 and multiply it by the contents of this bracket, which gives us this here. So we take x squared, multiply it by this, plus 2x, multiply it by the terms in this bracket, plus 1 multiplied by the contents of the second bracket. Now we're going to remove the brackets. X squared times x squared give us 3x4 to the power 4. X squared minus 6x are going to give us minus 6x cubed. And x squared minus times minus 1 is going to give us minus x squared. So this is using the distributive rule on the first bracket. We get this term, this term, this term. Now we're going to use the distributive rule on the second bracket here. When we multiply 2x times 3x squared, that gives us plus 6x cubed, plus 2x minus 12x gives us minus 12x squared, and plus 2x times minus 1 gives us minus 2x. So we've got the three terms from removal of the first bracket, the three terms from removal of the second bracket. Now we're going to multiply 1 times each of the terms here using the distributive rule. 1 times 3x squared gives us plus 3x squared, plus 1 times minus 6x gives us minus 6x, and plus 1 times minus 1 gives us minus 1. So we've removed the brackets using the distributive rule. Now again, if we want to collect like terms, we're going to write everything in terms of descending powers of x. So we take the highest power, which is 3x to the fourth, and this is the only term with x to the power 4. There's no other term up here, x to the power 4. Now we're going to deal with terms that are x cubed. So we have minus 6x cubed, and we have plus 6x cubed. So minus 6x cubed plus 6x cubed. So that's grouping the terms which are cubed, x cubed. Now we're going to group the x squared term, minus x squared right here, minus 12x squared right here, and plus 3x squared right here. Now we go to x to the power 1. We go to x to the power 1, we have minus 2x here and minus 6x here. So there they are here, and minus 1. So we've grouped the terms with the same power. Here's x to the fourth. Here are the x cubed terms. Here are the x squared terms. Here are the x to the power 1 terms. And when we add minus 6x cubed plus 6x cubed, we get 0. So there is no x cubed term because they sum to 0. Minus x squared minus 12x squared gives us minus 13x squared, plus 3x squared gives us minus 10x squared. So this term, and this term sum to minus 10x squared. The minus 2x minus 6x gives us minus 8x, and we're left with a minus 1. Now you have, when for example you're grouping terms, you'll notice 1, 2, 3, 4, 5, 6, 7, 8, 9, which is what we would expect from this. We need 9 terms. And here I have on the line lower 1, 2, 3, 4, 5, 6, 7, 8, 9. So you must always make sure that you count your terms and that you have the right number of terms. You could go from, when you go from here to here, you could put a little tick mark above something that you've moved so you know that you've already moved it. You can do that. So this is the simplification of this part right here. Now, when we have x minus y cubed, this is telling us to multiply x minus y times itself 3 times. So x minus y cubed give us this. Now what we're going to do is we're going to combine these two terms here. Combine these two multiplication by multiplication using the FOIL method, and then afterwards multiply it by this. So I'm going to leave this right here, x minus y, and then I'm going to multiply it. If I take this and use the FOIL method, the first times the first gives me x squared. The outer is minus y times x, and the inner is minus y times x, so it's minus 2xy when I combine the outer and the inner using the FOIL. And the last term is minus y times minus y gives me plus y squared. So I grouped these two together, multiplied them out using FOIL, and come out with this. Now I'm going to take the x term here and multiply it by the contents of the second bracket, and then I'm going to take minus y and multiply it by the contents of the second bracket. Take x, multiply it by the contents of the second bracket is right here. Then minus y here. This minus y becomes that minus y here times the content of the second bracket. So generally when we write these, we write them each term alphabetically. So you usually put x, y, and not yx because x comes before y in the alphabet. Now I'm going to use the distributive rule. X times x squared gives me x cubed. X times minus 2xy gives me minus 2x squared y. And x times plus y squared gives me plus xy squared. Minus y times x squared y, and now you see it doesn't matter, the order of the multiplication doesn't matter, I put it alphabetically. So I've said x squared y instead of y x squared. That's equivalent. Minus y times minus 2xy gives me plus 2xy squared. And minus y times plus y squared gives me minus y cubed. Now, what I'm going to do is I'm going to combine the x cubed becomes the x cubed, minus 2x squared y, and over here we have minus x squared y. So I'm going to group this term and this one because they're identical. Minus 2x squared y minus 1x squared y gives me minus 3x squared y. And now I'm going to group the xy squared term and the 2xy squared. This is a 1 in front of it, and this is a 2, and I'm going to get 3xy squared, and the last term becomes this. So this becomes this, this becomes this, and I group this term and this term to give me this term, and I group the third term and the fifth term to give me that. So I take 2 and 4 to give me this, 3 and 5 term, third and fifth term to give me that, and I now collapse to 4 terms. Okay, now in this problem I'm multiplying 3 brackets or terms which contain x squared plus y squared, x plus y, and x minus y. Now I can multiply. I know this will multiply quite easily together because when I use the FOIL, the inner and the outer cancel. So the outer is minus xy minus xy, and the inner is plus xy. Now you can say minus yx if you want and plus yx. That's okay as long as you realize the inner and the outer sum to 0. So really it's the first times the first gives me the x squared, and plus y times minus y gives me minus y squared. So now I've left this term exactly the same, and I've left the 5. The 5 is this 5. This is this. And these two combine to give me x squared minus y squared. So now we're going to multiply this, the contents of this bracket, by the contents of that, use the FOIL. And again, the inner and outer will cancel. In other words, the outer is minus y squared x squared, and the inner is plus y squared x squared, so they cancel to 0. So it's the first times the first gives me x to the 4th, and plus y squared times minus y squared gives me minus y to the 4th. And now I use the distributive rule. 5 times x to the 4th gives me 5x to the 4th, and 5 times minus y to the 4th gives me minus 5y to the 4th. So we combine these two together, and we just really have the first and last term because the inner and the outer cancel to sum to 0, and I get this. And then when I multiply this by this, again the inner and outer cancel, so it's the first times the first and the last times the last give me that, and then I use the distributive rule. Now in this problem I'm going to multiply. Here I have 4 brackets. It's easiest if I multiply this term by this one, because if I do that, again through FOIL, the inner and outer will cancel. I'll just have x squared minus 4, and then I have x squared minus 2x plus 4, which is this one, and I have then this one, which becomes this one right here. So multiply this term, the first one, by the third one, I get this. The second term stays the same, and the fourth term stays the same. So now how do I multiply these two together? I'm going to leave the first one exactly the same. I'm not going to touch this. I'm going to take x squared times the contents of this bracket right here. Then I'm going to take minus 2x times the content of this whole bracket, which is this term here. And then I'm going to take plus 4 times the content of this, the last bracket. So I leave this one the same right here. I put another bracket right here because I've got different sets of brackets here. So I use what's called a brace bracket to differentiate it from this bracket right here, called a brace bracket. Okay, so when I multiply this times that, I'm going to take the first term of this and multiply it by all of that. And I'm going to take the second term, minus 2x, multiply it by all of that, and then take the third term, plus 4, and multiply it by the contents of the third bracket. And that's what I've done. X squared minus 2x plus 4 are all in here. And this, and this stay the same. So now what I'm going to do is remove the inner brackets all over here. Just remove the inside. We always work from the inside out. So leave the brace bracket. X squared times x squared gives me x to the 4th. X squared times plus 2x gives me 2x cubed. X squared times plus 4 gives me 4x squared. Minus 2x times x squared gives me minus 2x cubed. Minus 2x times plus 2x gives me minus 4x squared. And minus 2x times plus 4 gives me minus 8x. Now, we still have to remove this one, so 4 times x squared gives me 4x squared, plus 4 times plus 2x gives me plus 8x, plus 4 times plus 4 gives me 16. So now I'm going to look at the contents of this and write it in descending powers of x. So x to the fourth here is this. This stays the same, so I haven't touched that. The x to the fourth is x to the fourth. I've got 2x cubed and minus 2x cubed. And those are the only terms in x cubed, so I'm grouping those together. I got plus 4x squared minus 4x squared plus 4x squared. So plus 4x squared minus 4x squared plus 4x squared. And then the next power of x is x to the power 1. Where is it? Right here. Minus 8x and plus 8x. So those are all both to the power 1. And finally I take the 16. And I set 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. So you should always make sure that you have the same number of terms when you're rearranging them in descending powers of x. Now, plus the x to the fourth is x to the fourth. The plus 2x cubed minus 2x cubed sums to 0. So there's no term in x cubed. Plus 4x squared minus 4x squared sum to 0, plus 4x squared gives me this one. So the sum of these three terms is plus 4x squared. The minus 8x plus the plus 8x sum to 0. These two sum to 0. And finally, I have 16. And there's my final answer right here. So there are different ways of doing these problems, even if you multiply this times this, and then you multiply the other brackets, you go sequentially, it becomes more complicated. So I've tried to do it more, take the two simplest terms, collapse them because they only combine to give two terms, and then multiply it out. There are more than one way to do this problem. And you can practice and see, but whatever you get, you should eventually get something that resembles this or is the same as this.